Thanks, Rashid. So probably in this next 15 minutes, I would like to share with you some of our observation related to the tubular structure being used in the modular integrated construction, mainly from the structure engineering perspective. So probably we're focusing on the, for example, on the steel tubular sections and also the joint, how those things will be correlated in this topic on the MIC. Probably I've been working on this area for tubular section for quite a long time. So every time I would like to encourage the audience to enjoy the aesthetic appearance of the tubular structure among the nature. Like on the left-hand side of the screen, you can see the beautiful tubular structure that in the Madrid airport. And also in Singapore, you can see that alongside to the nature, that you can see that the combination between the structure is actually sometimes quite aesthetic pleasing. So when we look at all these application, then obviously that we also think about it actually in terms of the modular integrated construction. So sometimes when we look what we have got around the world, actually we can see something similar already now. Sometimes probably in here in Indonesia, that we got all this bamboo structure that they make use of all the bamboo to build up the structure component. And on the right hand side, you can also see that the main structure skeleton being used for the bamboo tubular structures, and then you've got the cargo box inside. So it's beautiful that we can get all this structure in place. But when we look into the major modular integrated construction, so probably we will think about is a box-like type. So like from the earlier presentation from Dr. Kim, that sometimes we have to ship the precast component. At the same time, actually, we also need to ship the box to the site as well. So when we think about the box, we inside the box or outside the box, we got the column, we got the beam, and the beautiful things that what we can do now. Probably when we look into the tubular family, we have a lot of different cross section that we can pick up to try to make it as a column. For example, as shown on the screen, we have the so-called rectangular section, hollow section, box, square, circular. And then probably depending on our application for low rise, medium rise, high rise, then actually we can think about what particular material we can use using the typical string steel we got, or we could use a higher string steel that we can adopt in combination with other material. We can get those products off the shelf, so you can get it from some of the manufacturer, or actually you can tailor make it to suit your own project. The next few slides, I just want to show you some very general fabrication method that you got for tubular section. The first one is related to the so-called cold form section. How can we make those circular or square? So when you look at on the left-hand side, that those hollow sections actually originated from a coil that we got, and then you uncoil it, and then you try to roll it and then weld it to form the hollow sections. Mainly circular first, and then you pass through some press breaking process, then to form the square or rectangular section, and then go for the construction site. Here you can see that there's no particular temperature involvement here, so we call it so-called cold form. And there's another type of construction manufacturing process that we call it hot finishes. So as the term mentioned, that means something at the end is hot. So look at the on the right-hand side figure, very similar to the cold forming process or uncoiling, rolling, welding. But at the end of the process, we'll try to put it in the furnace, try to minimize, because if you think about once you got this cold form process, you roll the section, you press break it and you weld it, you sort of lock in some stresses inside the product. So if we try to relieve those stresses, then probably we can try to make use of some hot bath, just like when you are under stress, then you go to some sauna on that. So probably after we've got all these things in here, then you can see that under hot environment, then you can try to shape it again to square, circular, whatever you want. So again, we call it hot finish. Obviously, then you can get that there's different performance about cold form and hot finish. they're all, again, it depends on the manufacturer, what they got in the place. Well, if you haven't got the chance to buy those products in your area, then probably the easier things that probably you can buy some steel plates and then you can try to fabricate, tailor-make your own. So here we can have the so-called fabricated section. Here I show some of the equipment that we got in PolyU from the industrial center. We call it press brake. So basically that you have the plate, you press brake it, and then form the half section. Like in this kind, we also can get the chance to use the robotic welding. We got the robotic welder in the CNERC, so we can weld it. So you can make whatever you got. And then again, it depends on your project size. So again, depends on the volume of the product you got. Then obviously the cost involvement that will be interesting to look into. So we have this cold form, hot finish, tailor-made, and this family that you can see that we have looked into the square, rectangular, circular, or elliptical. And this day, for some reason, I tried to look into orthogonal as well. So try to make use of different tubular section for different purposes. So those particular cross section, that obviously it depends on their section size, their cross section arrangement. There will be a different structure performance we have to look into. Again, from structure engine perspective, sometimes we need some equation or formula to show, okay, so if we get the chance to think about some of the basic formula, for example, if you got the piece of paper or a plate, then you simply press it, then you can see that it may buckle based on whatever you got, how thick or how wide the plate. If you got a can of Coke or you've got a cup and then you can try to press it, obviously we cannot press it, but if you get a can of Coke, then you can press it, then you can form the shelf buckling failure. It also relates to the thickness and diameter. So that means when you think about the fabrication of all those sections, then you have to think about the thickness, what you want to achieve. So obviously, the lighter the better. But once you've got the lighter, that means you're using the thinner section, then you're subject to all this failure pattern. So all these things is quite crucial for us because if you apply all this section that in your MIC or any structure application, obviously then we have to, in structure engineering, you cannot get away that we have to do a lot of testing, simulation, and then try to get the design rules. So that's why probably when you look into in the code of practice in Korea or in different regions, there are lots of design code. Actually, it's very similar around the world because all of the physics is the same amount, like low column buckling. And then you can get a lot of different code practice. For example, in Europe, they have the code to talk about the column buckling curve. If you recall earlier, I mentioned about the cold form, hot finished product. So when you look at for example, in the column buckling curve in Korean code, you may figure out that there may be a difference in terms of design, simply because of the manufacturing process, some embedded string. So I think that's something that's quite interesting to look into. One thing, so far we are talking about the hollow tubular section. Then obviously, as we mentioned, if you make to low rise, medium rise, high rise, so probably when you stack up the structure, the boxes, so you may have to get a higher load bearing column at the bottom boxes. So in those cases, if you want to keep the same size of the tube, then probably the next thing what you can do, you can try to put the concrete in. So that's why we can have this so-called concrete fill section there for high-strength concrete, high-strength steel, so that you can maintain the outer size of the column, but then you can improve the strength in the lower part of your MIC structure. So all this thing is quite interesting. But everything I talk about is related to the tubular column. But when you look at the box, we also got the beam. In the figure I showed you in here, probably the top part is actually it's not a steel section. It's actually related to the fiber reinforced polymer beam. But here, I just want to show you that on the left-hand side, you can see actually, if you have an open section, like a channel I section, if it's under bending, probably it will move sideways because of this openness of the cross section. But then if you got a closed section, like what you got in the rectangle, like the bottom part, then you can see actually he have very good torsional rigidity. So those things actually is quite good from the structure perspective. So we have the column, we have the beam of the box, and then the next thing probably is quite important at the end of the day, the joints, the key things about those MIC issue. So we have to take into account within the beam and column, how we're going to connect it. relate to the strength, stiffness, ductility, the failure mode. So basically, actually, if you look at the early file, we have the column, we have the beam. Normally, we try to weld it to make a monolithic structure on this part. So there's a lot of existing code working on those areas. For example, the ISO welded hollow joint, they focusing on different failure modes of this different configuration, as so on the right-hand side part. So it's beautiful. All this design rules there. And then the question you will ask, everything we use is for the welded joint. So how about, is there any chance that actually we can try to bolt it between the hollow section for the beam and the column as well? Yes, I think we also need, there's a different perspective about those things. I think for us, probably we can, there's a so-called one-side bolting connection that if you look at the top right-hand corner, actually we can also use some one-side bolt to connect the beam to the hollow section as well. So again, if you got a welded joint, the bolted joint, obviously there's something different between the stiffness, that kind of thing. So again, we have to investigate on all those issues. So we have the intra-modular joint. Then how about between boxes or between the MIC? What do we need to consider? Then obviously, I cannot get away from the structural engineering perspective. We have strength, stiffness, ductility, and failure mode. So that's why every time, probably we can learn from what we have got existing for bamboo structure, like in here, or there's a lot of joint actually acting between two boxes. Even in Hong Kong, probably Dr. Kim, when you were in Hong Kong in the last couple of years, you can see the bamboo structure that actually is interesting. Even for me, I still find it interesting to get this part. And you can get the feeling that they can connect those things. And the beautiful thing is how we're going to observe, to test, to evaluate. I think that's beautiful. But after I look at all these things, then I just go back to my, in my childhood, haven't got a chance, but I think I just asked my student, how about can we build some brickwork structure to get the feeling how they're going to connect. So when we look at the literature, actually in early 2015, actually there's a paper talking about how those interlocking blocks to talk about shear momentum is beautiful. I think it's quite nice for us to actually, structure engineering is everywhere. So we look at that part to think about the joint, and there's so many things that we can observe from this side, and actually from 2008 up to earlier, there's a lot of different existing joint being put in place in the literature. So welded joint, bolted joint. So beautiful. We have to see how that is going to affect the structure performance. Some of the joint actually, they require to put a hole in the column. So then, okay, because of the accessibility, we have to think about if the structure component got a hole, like in here, if you got the beam, sometimes we got the hole to pass through some surfaces. Beautiful, we got it, because it can reduce weight, reduce the construction depth, and then we can try to work out the structure performance. Similarly, if you got a hole, no worry, we can try to figure out how the load is going to spread using some investigation on that part. So all these things is quite important from the structure perspective, because if you got the joint, then structure engineering, we cannot get away from testing, numerical simulation. That's why we have to, no matter what happens, we have to carry on to observe the strength, ductility, stiffness, and failure mode. Whatever we see, we touch, we got the feeling. But sometimes we also think, we know all these structural components well designed. But what happened about if suddenly we remove one of the components of the structure system, in particular in this modular structure, then what will happen? Like in here, if we remove one column from the modular, how the corresponding stress being redistributed? Can the member can sustain the loading, or the joint, can it be sustained all this additional situation? So it's beautiful things we have to look into. And also we need to think about it. How about the constructability or buildability? So that's why probably sometime before the construction, we can think about, like on the top part, we can print the product very light, so we can get it. So we sanitize the things. But at the same time, we can get this modeling to get the insulation. Then you can get the feeling, wow, for two story, even for ourselves, when we try to build this part, there's so many difficulties, even within for us. So if you put it in the wheel structure, it's very difficult to think about the logistic or the constructability. But at the end of the day, once we go all this technique, the most important thing is actually how we try to encourage, including the teaching or the education part. So that's why we have to get involved, the undergraduate or the postgraduate, to get involved, to get some real physical training about this kind of 3D printing, and get the things to be shared. So I guess among all these things, hopefully, within all this collaboration, we can get the chance to understand the MIC from structural perspective. So I'm overwhelmed for the second. But before that, I want to thank for my student, former and current student, for the work in terms of the work. Okay, thank you for your time.